Hi, I'm Thomas of Primary 6 from YUMIN Primary School. This time we're still at ordinary differential equations. Well, in ordinary differential equations, we have many examples. But all of these examples, we need to know what type of methods we can use. And even if you just know one type, you need to know how can we use it with other types of methods. How can we make a combination out of all of these? So right now here, we'll take a look at what example we have. So for this example, y second derivative plus 4y first derivative plus 5y, and this is e to the power of 3x plus x squared. Right now for this part. Firstly, what type of example is this? Linear. Constant coefficient. Non-homogeneous. Non-homogeneous. Then you have to use yg, that is yh plus yp. Okay. So in this part, what can we use? Firstly, let's just find yh. Now for yh, it will be y second derivative plus 4y first derivative plus 5y equals to 0. So at this part, now what do we have? So at this part, we just use characteristics equations. You get something like this. But next question, can you use factor theorem straight away? Can you use cross multiplication? No. So for this one, you'll try out quadratic equations. For quadratic equations, you have two roots, as this is lambda squared. So it is. So this is negative 4, then plus minus, square root 16 minus. So this part is minus 20. Then this divided by 2. Then after that, negative 2 plus minus I. Okay, this part is what you'll get. And that means yh would be c1 e to the power of negative 2 plus I plus c2 e to the power of negative 2 minus I. Okay, the next step, you can use the hyperbolic functions and Euler's formula. At this part, what do you have? So for Euler's formula, well, x. Well, these parts, they all have x. Okay. But here are times these hyperbolic functions. So this part, let me just write it below. Okay, this is what you have. So this will be your YH. Next part will be your YP. So after that, for your YP, well, what you'll have is let. But let, what would you need to let? Let YP be, here this part you have e to the power of 3x, but here don't have. So okay, e to the power of 3x, but you don't know how much of these do we have. Then after that, you have x squared. Okay, bx squared, then cx, then d. Okay. Next part. Now what would you have? First derivative, yes, you need it. Then the second derivative. Okay, so this is what you have. Then after that, just sub all these back inside. First thing is the e to the power of 3x. 9, 3 times 4, then 5. E to the power of 3x. And this is e to the power of 3x. So that means, okay, here's 26a. And 26a is 1. So a is 1 over 26. Next part for b. Here b, here's 5b. So 5bx squared will be x squared. So 5b is 1. And so b is 1 over 5. Next part is here, x. So here is 8x, no, this is 8b. Then after that is 5c, then x. And this is 0. So that would mean 5c is actually negative 8b, which is negative, okay, so c is negative 8 over 25. Next part, constants. So here, 2b plus 4c plus 5d, and this is 0. This part, 2b. 2b, 2 over 5. 4c, 32 over 25. Then plus 5d, and this is 0. So this is what you should get. 22 over, let me just think. Yeah, I think this is right. Okay, so this is what you should get. So then yp will be, okay, a is 1 over 26. Then b is 1 over 5. Then c is negative 8 over 25. Then d is here. Okay, now this is what you get for yp. Last part, add them all together to get your general solution for your non-homogeneous ordinary differential equations. Okay, so this is what you should get. And this will be your solution. Okay, so if you want to verify this, well, you can verify by yourselves. So for this time, I'll end it here. So I hope that you're all clear. So if you like our videos, don't forget to subscribe to our channel, and thank you for your watching.